To transfer tokens on Solana, you need associated token accounts for both the sender and recipient. Each ATA is linked to a specific mint. Only the source account owner can authorize the transfer. Now let's look at how the account state actually changes. Before the transfer, the source ATA holds an amount of 10,000 base units, which, with 2 decimals, equals 100.00 tokens. The destination ATA holds 0. When the token program processes the transfer, it decrements the source by 50 and increments the destination by 50. After the transfer, the source has 9950 and the destination has 50. This is atomic. Both update or neither does. Here's how the token program executes the transfer checked instruction. It receives the source token account, the mint, and the destination token account. First, it verifies the signer matches the source account owner. Then it checks that both token accounts reference the same mint. It also confirms the decimal count matches the mint's configuration. Only after all checks pass does it update both balances. Now let's walk through the Rust code. We start with the use declarations. From anyhow, we import result for error handling. From Solana client, the async RPC client. From Solana SDK, we import pack for deserializing account data, key pair and signer for key management and transaction. From Solana system interface, we get create account. From SPL, associated token account interface, we import get associated token address and create associated token account. From SPL token interface, we import the token program ID function, initialize mint, mint2, transfer checked, and the mint state struct. We declare an async main function with the Tokyo main attribute. We create an RPC client connected to a local validator with confirmed commitment, then fetch the latest block hash. We generate 2 key pairs, fee pair and recipient. We airdrop 1 SOL to the fee pair, confirm the transaction, and loop until confirmed. Then we do the same for the recipient. Next, we generate a key pair for the mint. We get the mint account size using mint::len and fetch the minimum rent. We build the create account instruction with the pair, mint address, rent, space, and token program ID. The initialize mint instruction sets the token program, mint address, mint authority, an optional freeze authority, and 2 decimals. We calculate the source token address, the ATA for the fee pair, using get associated token address with the owner and mint. Then we build the instruction to create it, passing the funding address, wallet address, mint, and token program ID. Similarly, we calculate and create the destination token address for the recipient. We set the amount to 10,000, which is 100 tokens with 2 decimals. The mint2 instruction targets the source ATA with the fee pair as authority. We build the setup transaction with all 5 instructions: create account, initialize mint, create source ATA, create destination ATA, and mint2. We sign with both the fee pair and mint key pairs, then send and confirm. Now the actual transfer. We set the transfer amount to 50, or 0.50 tokens. The transfer checked instruction takes the token program ID, source address, mint, destination, owner, signers, amount, and decimal count. We build a second transaction with just this instruction, sign with the fee pair, and send it. Finally, we fetch the mint account and unpack its data using mint::unpack. We also fetch both token accounts to verify the balances. We print the results: mint data, source balance, destination balance, and the transaction signature.